Hello team, today's challenge is bucket fill, where we're given a matrix that looks like this. It can actually change. You'll see some of those down here. A starting position and the new value. So we go to the starting position, which is 0, 1. That would be the 0 row and the 1 index, which is this G, and we change it to B. And then we look around that and we see if there are any other top, left, right, or bottom values where they are also G. In this case, it would be index 1. What would that be? 1, 1, right? 1, 1. At which point we change that too. And we just keep going until we have filled all of those spots. It's kind of hard to visualize this way. So what I've done is I've taken test 4 and test 5, and I've made them a comment to help visualize this. More for me than for you, but hopefully it helps you too, okay? So what I did was I took that test, right? It's going to be, we're starting at 0, 3, we're changing to Y's, and we have this, okay? So 0, 1, 2, starting at 0, 0, and then 0, 1, 2, 3, which is the T. And I've marked that with an asterisk down here in the second one, okay? At which point, now that I know it's a T, I got rid of everything that wasn't a T. So the T's are the only things in here, and we can start to run the course. So we have that asterisk, that's a start. We can go down because that's a T, that's a T, that's a T. We go left, TT, and then we have this fork where we can go left and up, 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 and left, right? And the left, right. There's a joke. The final result, though, is that all of the T's change to Y's because they all touch another T, okay? With the second one is very similar. So we start at 2, 2, and we're changing to G. There's already some G's in here, but we go down. So 0, 1, 2, and then 0, 1, 2 is this B right here, which I've marked with that asterisk. Now that I know that it's a B, I get rid of everything else, right? So we just have this. And in this case, we don't have, we have some of these B's where they don't touch anything. The ones in the corners, right? The ones in the corners don't really touch anything, which means that we can only go up, left, up, and we're done, right? Because there is no B here or here, we can't change this B. No B here or here, right? We can't change that B. Kind of the same with these. They're back to back, but we have no way of getting to them. So we only change those centers, which means that our final result still has these 4 B's in place, and we've only changed the middle ones. Hopefully that's making sense, because that's, if we just go and blanket change all of our B's to G's, it will be wrong. That's not what they're asking for, okay? So with that, my first concern is grid. To a lesser extent, row and column, we're doing some destruction there, so probably pretty safe. But grid itself, the matrix, is being passed in by reference, right? And you've heard me talk about this on other videos where if we make any changes to grid inside of this function, it will affect any places where we might use grid outside of this function. And we don't want that. That's not a great place to be, because that's side effects. How would we ever track those, okay? Instead, what we do is we make a new grid and we operate on that every single time. That way this function is functionally pure, right? We get a good system in, and we can do that using, in this case, I want to use let. You'll see why in a second, but we're going to call it new grid equals the grid, grid.map, sending through the row and creating a new, just like this, a new row, okay? And this is one of the faster ways to do this. We could use something like structured row. We've used that in recent challenges, or there are a few other ways to get this done, but this is going to be the easiest way. If we only, as an example, if we take this and comment it out, if all we did was we set grid like this, well, great. We've created a new copy of the outer array, but all the original inner arrays still point to grid as well as new grid. So any changes to the inner arrays on new grid also change the inner arrays on the old grid. Okay, very important to know that. I can test that right now by going console.log, going new grid, triple equals grid, brilliant, and new grid 0 triple equals grid. Not like that, 0. Cracking open my dev tools, clearing it out a little bit, running it. It's going to return false and true, okay? Because the second one, these are the same spot in memory. That's how we get truthy arrays and objects, okay? They have to be the exact same place in memory. If they aren't, then they're false. And we get that with this line. So we go and get rid of this because we don't need it anymore. Clearing out my dev tools, running it, and getting all falses. This is where we want to be, okay? The downside of this is that we're going to do it every time we call bucket fill, but there are ways to optimize around that, right? I'm not going to get too deep into that today, but this is where we're going to leave it. And it is pretty fast, okay? So with that, we have our grid, which means that we can go const. The old value is going to be equal to new grid. We could have actually just used grid here, but I'm going to do it this way. New grid for row and col, okay? Now that we have that, we can go and do the replacement. So we take the same thing and we just set it to new value, okay? At this point, what we want to do, besides returning new grid, okay, is we want to iterate on up, down, left, and right, okay? Now for that, I have just a little bit of code to save us some time. So I have the adjacents. We have up, down, right, and left. Up, down, left, and right. Adjacents, it felt right when I first did this. I feel like calling this directions, honestly. That feels a little bit better. But up, down, left, and right. And we iterate over these to see if any of them match our old value, okay? So with that, I'm going to go for let dr and dc of directions. If you watched my recent video on Connect 3, this should look very familiar. This is the inner part of that system, okay? At least the loop is. Some of the things change inside, but hopefully this is feeling kind of familiar, okay? And in fact, this next one should be too. So we get the row and the column, and that is going to be equal to row plus the direction of the row and column plus the direction of the column. Excellent. Okay. From here, we diverge a little bit. We still need a conditional. So we take that new grid, just like this, new grid, not new grief, but new grid for the row. Wow, my arrow keys are bouncing around, just like this. There it is, okay? The row and the column, making sure that that is equal to old value, okay? So that gets passed in, and then we do something. But before we do that, we need to talk about this. Again, this is, we talked about this a little bit in Connect 3, but there's a chance that if row doesn't exist, if we've gone too far up or too far down and we are outside of our little matrix that we've created, then everything blows up because you cannot find whatever this value is going to be off of something that is undefined, right? So to fix that, we're going to use some nullish coalescing, just like this. Optional chaining, not nullish coalescing, optional chaining. And that should solve that, at which point we do a reassignment. So new grid is equal to what? Well, it's bucket fill. Surprisingly, we're going to do some recursion, right? We're going to pass in our new grid, just like this. We're going to pass in our new values. So that's going to be row and column. And of course, our new value, okay? At which point, everything kind of just falls into place. And I'm not sure why I left my dev tools open for so long, but here we are, okay? We absolutely have it. We created a brand new matrix. We did that because we don't want to affect anything outside of this, okay? Which means that as we go through and make edits and changes to our grid, we want this to be functionally pure. We want to return a brand new thing. And again, nothing outside of this should should be aware of what's happening inside. Okay. Which means that we did that. We got the old value. We set up our first new value. Okay. That's easy enough. And then from there, we looped over our directions. There are only 4, so it should be pretty fast. At which point we did it. If that old value appears in one of those 4 directions, then we run this again and we do the update. And every time we make a change, we reassign it so that, right, it's assigned up here so that when we go through the next one, it is going to make changes to the most recent information that it has. Okay. And that's it. Again, if we wanted to go diagonally, we could update this to do diagonalies as well. But building on previous exercises, right? That Connect 3, that tic-tac-toe, doing something similar here where we can go in and make this work. Okay. And the easiest way that I found to do this is to add those comments, right? The comments really help me get my thinking straight on how this should work. Okay. Without that, I probably would have floundered around a little bit. It went very fast because of those comments. Maybe you think otherwise though, right? Do you like comments? Do you hate comments? Do you like this? Do you hate this? Did you go a different way? Let all of us, let me especially, know all that good stuff inside of the comments, the YouTube comments, not these comments, obviously. Otherwise, for today, this has been Bucket Phil, and I will see you tomorrow.